This is a brain. Inside it, billions of synapses are firing every second. And I thought it was a good idea to simulate a brain in C++. But first, how do we even start? Well, brains are made up of neurons. You probably already knew that. And to simulate it, we need to make some neurons too. Surprisingly, it's quite simple. All we need is some inputs, some weights that control how much each input matters, and a bias, which is added on top of the sum. Then we'll link all the neurons together and bam, we have a brain. Kinda. In fancy computer science words, this is a neural network. So now it's about time to look at the code. This is how a neuron looks behind the scenes. Quite simple. The interesting part comes when you need to link all the neurons dynamically. I used a method with layers, where each layer is just a vector of neurons. This is a function that takes the outputs of the neurons from one layer and puts them in the neurons' inputs from the next layer. In the end, it was surprisingly easy to implement a demo of the neural network. But it's not over yet. You see, all the weights and biases are currently hard-coded. But if we want our brain to actually learn something, we need to implement backpropagation. In short, a neural network makes a prediction, compares it to the correct answer, and then adjusts its weights to reduce the error. First, let's upgrade the neuron by making it store the output and delta. The delta is basically just how wrong the output is. For the output layer, each neuron's delta will be the output minus the target. For the hidden layer, we can calculate each neuron's delta as being the sum of each of the next layer's neurons' weight times delta. You can update the weights and biases values using this formula, where the learning rate is basically how fast your neural network learns. But be careful, because a high learning rate can lead to very unstable neural nets. Finally, we just have to put it all together in a training loop. The neural network does a forward pass, calculating the output, then a backwards pass, changing the weights and biases. After doing some quick tests, our program works. We now have a simple working neural network. There's so many possibilities. Although, this neural network is linear because it doesn't use any activation functions. So, it cannot learn complex patterns. And it's surprisingly simple to change that. And now, finally, we have a neural network that can learn basically anything. And I learned a lot from programming this, and I definitely recommend trying to make your own neural network. If you do, I hope this video gave you at least some directions on where to start. I guess that's all. Bye and have a great day.